And now we're going to create a new study. So let's go to simulation and let's go with new study. Static, and let's go with the name sheet metal. And the software automatically recognizes the sheet metal structure as a shelled structure made of 2D finite elements. So only that we have to define this material. So let's go to part, material, and let's go with alloy steel, apply, and close. And now we don't have to define the thickness, because thickness is automatically extracted from the thickness of the sheet metal to the thickness of the shell. And we don't have to define the connections. We only have to define the fixture, so we can right click on the fixture. We can go with fixed geometry, immovable, but now we can apply the fixture on those cross faces. Here, here, those 4 holes, here and here. Like this, and OK. And now we can define external loads, right click. We can go with gravity, top plane, and OK. As well, we can add a force on this face, and we have 10,000, and OK. And now we're going to find the mesh. So the software extracts the mid surfaces and generates shell mesh at the mid surface. So let's go right click, create a mesh. Let's go with curvature based. We have the same parameters, 4, 1. Let's go advanced, draft quality mesh, and let's click OK. And this is our mesh. And now we can run our study. So we have here stress, displacement, and strain. And we can see that the highest stresses are located at the banded edges of the sheet metal model, here and here. And when we used surface, we didn't have high stresses right at the edges. So the radius of the band influenced the maximal stresses. And with their modification, we can reduce or increase the stresses. Let's go here to results. Let's define the factor of safety plot. And now we see that we have the minimum factor of safety 1.6, and with the surface we have 2.28. So if we compare the surface and the sheet metal, we can see that the highest stresses in the sheet metal are right at edges, and with the surface they're not right at edge, because here we have edge that is welded. The factor of safety, we have here 1.6 and 2.2. So now we have to choose between surface and sheet metal. We would choose surface because of the welded edges. With the welded edges we have less deformation at edges, and with sheet metal we have vulnerable zones that are located along banded edges. And as we saw, we have a higher factor of safety with the surface. So because of the higher level of safety, we would choose surface. So to recap, when you do the static analysis of the shell body, you can develop a CAD model using a surface tool, and you can develop a CAD model using a sheet metal tool. In our case, when you develop a model with surface tools, we got a better results.